Hello all. In this lecture we will see about layered arrangement of modules and two different approaches to software design. So we have already seen layered arrangement of modules is a better option while we design. So there will be a control hierarchy representation for the whole program components in the program, in the software. So it will be a better idea if you represent using this layered arrangement. So it is actually a tree-like structure, and we will see this tree-like structure, this structured arrangement in when we learn structured chart. So when we learn function-oriented designing, we will be learning about structured chart. So structured chart is a tree-like representation, similar to this diagram. So it is like the architecture, the software architecture will be represented in this in this layered manner. So it is a good solution. We have already seen that it's a good design solution to do layering of the modules. So if we could layer all these modules like this, it's a good design solution because it achieves control abstraction. So it achieves control abstraction, and also it is easier to understand and debug the modules or the program. So if you want to understand, if we have this layer structure, it will be much more easier. And it also provides a control abstraction. So control abstraction means there will be everything will be hidden. So if you check M2, for M2, M1 is completely hidden. M2 need not access anything from M1. Okay, similarly M3 or M5, M5 does not know anything about M4. So there is an our control abstraction is there in these modules. So when we do this layered arrangement, it's a good design solution because it achieves control abstraction and it is easier to understand and debug the modules. Here we have some terminologies. The topmost module is known as the manager module. So this module is known as the manager module. Then modules in intermediate layer. So we have different modules in intermediate layer. So if we check the modules in intermediate layer, it provides services to their higher layer. So all these are intermediate layers. So these modules will be providing services to higher layers. So if there are several different structures below M5, so this can also be considered as an intermediate layer. So it will be providing service to M4. So it will be providing services to the higher layer, and it invokes services of lower layer. So M4 will be invoking service of M5. And similarly M3, if there is another submodule, it will be invoking service of this lower layer. So this way this layered arrangement of modules goes on. So what's the advantage of this layered design is understandability increases. So it is easy to understand one module. So if you have this layer like structure, it is very easy to understand what is happening inside a module. So when understandability increases, we can isolate the errors also. Error isolation is also possible because if there is an error in M3, it will not affect M2 or M4 or M5. So this is happening only inside this. So it is easy to debug this error. So if there is a error in M4, then need not worry about M3 and M2. It has to check M4. If it has no problem, then it has to check only M5. So that error isolation is possible. So failure of one module do not affect others. So that is the advantage of this layered design. And debugging time also reduces because we can fix that module only. The other modules has no problem. So other modules have no problem. So we have to check for this M4 only. No, there are some terminologies that are used in this layered structure. We need this terminologies when we learn this function-oriented programming. So you have to know these terminologies. First one is superordinate module. So superordinate module. So if you check this, there are different kinds of modules here. Superordinate module. It is a module that controls another module. So M4 is a superordinate module because it controls M5. Similarly, M1 is a superordinate module because it controls M2, M3 and M4. Then we have subordinate module. So a module which is controlled by another module. So if you check this diagram, here M5 is a subordinate module because it is controlled by M4. Similarly, M2, M3, M4 are subordinate modules of M1. Then visibility. So B is visible to A if A directly calls B, then only B is visible to A. Otherwise, there is no visibility. So if A is a module and if it is directly invoking B, then B is visible to A. Then what do you mean by this control abstraction? So module should invoke functions of modules that are in layer immediately below it. So it can invoke only modules or functions of modules that are in the layer immediately below it. So that principle is known as control abstraction. So when we bring this layers architecture, we can bring this control abstraction also. So it should, all the other modules are hidden to the module. So in this module, if we check this, so there is control abstraction. So M1 needs to call only this M4, M2, M3, and similarly M4 has to invoke only M5. It need not worry of other modules. So module should invoke functions of modules that are in layer below. Then there is another terminology called depth and width. So depth is the number of layers in the module. Depth is the number of layers in the module, and there is another terminology called as width. It is overall span of control. We will see this example. Depth means, so this is at layer, M1 is at level 0, this is at level 1, and M5 it is at level 2. So this is a 3 level module. So we can say that the depth is 3. Depth is 3 because this is level 0, 1, 2. So there are 3 levels. So depth is 3. And if we consider the width, maximum width is 3 because we have only maximum 3 modules from M1. So width is the overall span of control. So width is the overall span of control of the module. Okay. So width and depth is 3 in this case. Then there are another two terminologies, fan out and fan in. So fan out, it is a number of modules that are directly controlled by a given module. So M1, the fan out is 3. So M4, the fan out is M5. For M3, fan out is 0 and M2 fan out is 0. Okay. So fan out is a number of modules that are directly controlled by a given module. Then fan in is there. It is a number of modules that directly invoke a given module. So if we check M4, the fan in is 1 because it is invoked only by M1. Similarly, fan in here, it is only 1 because it is invoked only by M1. Similarly, for fan in of this module is 1. For M5 also it is 1. So if there is a connection from M3 to M5, then we can say M5 has fan in 2 because M3 is also invoking M5. So that is fan in and fan out. Then we will see what are the different approaches to software design. So there are mainly two approaches in software design, and they both are different. So these are two different approaches to software design. So in earlier days when we use structured programming and procedure-oriented programming, we are following this function-oriented design. Later when object-oriented programming and all came, we started developing these UML diagrams and all. And now object-oriented design is also there. Okay, so these are both contradicting things or complementing techniques. Okay. So we'll see. So in the next chapter, we'll see about function-oriented design. Later on, we'll see about object-oriented design also. So we'll learn both types of design, and we'll learn how to design the software using both these approaches also. So we'll just see an introduction to this function-oriented design. So it is actually a top-down decomposition approach. That is, a system will start with from a black box. That is, it will start from the name. For example, if you want to develop a college automation software, then college automation software is a topmost level, high-level function. So we'll start with a high-level function. Then we try to find out the sub-functions of that college automation software. So we might get some 5 or 6 functions, sub-functions that can be included in this. Then again we try to learn each function, and we try to again find out sub-functions of each function. Like that it will go on. So it is known as top-down decomposition. We will start from the top and we will decompose to we will go downwards. So it is a like top-down approach to top-down decomposition. We call it as top-down decomposition. So we start with a high level view of the system. So each high level function is again refined to more detailed functions, and those functions are again refined and refined. So we'll see an example. So if you want to create a new library member, so this is a high level function. So here we have to give a create a new member. We have to assign a new membership number. Then we have to print a receipt for that person. All these things should happen. So these might be the sub functions that will be there. So for example, in this case, if we want to create this new library member, sub function will be we have to assign a membership number. So that is one of the sub functions. Then we have to create that member record. That is another sub function. Then we have to print a bill, a receipt for that person. Then that will be the third sub function. Similarly, we decompose into three sub functions. Again, each sub function, if print bill, again may have to call some other sub functions. So we'll start from a top level function and we try to decompose into sub functions, and sub functions like that we will go on. So that is known as function oriented design. So here higher level functions are refined into some functions. Then this will be these three will be the sum of the, maybe we will divide this high level create new library member into these three sub functions. And again, maybe assign membership number may have to call some other functions. They might have some other function happening inside that. So it will invoke another function. So we'll again divide it into some two or three sub functions, like that it will go on. So this is functional oriented approach. So in functional oriented approach, there is a central system state is there. So this central system state can be defined as the values of certain data items that determine the response of the system to a user action. So it is values for certain items that are there in the system when a user invokes a function. So if this function is invoked, create new library member is invoked, then what happens to the system state? So some of the data elements will be updated, some data records will be updated, and it will be changed to some other state. So that state is known as a central system state. So there will always be a centralized system state in the case of object in the case of function oriented approach. So example, a set of books determines the state of library automation system. So if you take the library automation system, all the set of books will determine the centralized state of that system. Okay. So system state here is centralized and shared among different functions. So this central state is shared among all the functions that are using this system state. Then second type of design, so we have different function oriented approaches. There were different people who were working on this function oriented approach. We have Jackson structure design, then there is stepwise refined by birth, then there is Hartley's sphere-wise methodology. Like that, there were different methodologies that were available during function oriented approach. So those approaches were mentioning how to design softwares using this function oriented approach. Okay. Then came the object-oriented approach or object-oriented design. So here it is a system is viewed as being made up of a collection of objects. So it is viewed as a collection of objects, and each object is you have already learned about object-oriented programming and all in other subjects in BTech and all. So you are aware of what is this object-oriented design and all. So system will be viewed as a collection of objects. So it is a collection of real world objects, and each object has some function. We call it as methods, and this or each object contains will also contain some data. Okay, so each object will be having some methods and data. Okay. Data internal to an object cannot be accessed directly by other objects. Only through it can be accessed only through invocation of methods of objects. That is, if some data is available for an object, and those data cannot be accessed by um, cannot be accessed directly by other objects. So if we want to access data of some object, then you have to call method of that particular object. Then only that data can be accessed. And you have already learned about data encapsulation and all. So there is a data encapsulation method in object-oriented approach. So data encapsulation, data hiding is there. So whereby data is hidden to outside class also, we can hide those data. So it's a, we'll see that data abstraction and all. So here the system state. So in the earlier case of function oriented approach, we have a centralized system state, but in the case of object oriented approach, there is no centralized state. It is decentralized because there is no global shared data in the system. Every object will be having some data, will be manipulating some data. So here it makes extensive use of abstraction and decomposition. So these two are the most important principles in design. We have already seen the first chapter. So in order to overcome the human perception complexity, that complexity, so we introduced these two terms, abstraction and decomposition. So this object-oriented approach uses use these principles of abstraction and decomposition. Okay, they extensively use this techniques, abstraction and decomposition. So object decomposes a system into functionally independent modules. So objects are instances of abstract data types. We call it as abstract data types. So we already know about these abstract data type and all. First one is data abstraction. So an entity external to the object would have no knowledge about how data is exactly stored, organized, and manipulated. If you have learned some object-oriented programming, you have seen protected variable, private variable and all. So if it is private variable, nobody can access those data from outside. Or if it is a protected function and all, only its derived classes can access those functions. So in this way, we can bring this data abstraction inside this uh, object-oriented design. So it is possible in the case of this object-oriented design. Then there is another thing, data structure is there in abstract data type. So you have already learned this data structure. It is constructed from collection of primitive data items. So we know what is a data structure. It is a way of organizing this data. Okay. Then you know what is a data type also. So these are the concepts that are used in abstract data type. So all these things will be there when we use this abstract data type. Okay. Then data type also, you know, integer, character, all these are known as data types. So we have abstract data types in the case of object-oriented data type or object-oriented design. So abstract data type was already available even before this object-oriented approach came. So all these concepts were available in most of the programming languages in the which were designed earlier, even before object-oriented approach came. You have already seen this data abstraction, data structure was there in C and all, data type was there. So these are all actually abstraction of something. So these are all actually abstract data types which were used in previous programming languages. So advantages of using this abstract data types. One is data of objects are encapsulated within the methods. So there is data hiding is there. So object data are encapsulated within those methods. So only the methods of those objects can access the data. So that is known as data hiding. You've already seen, you know what is a class and all. Class, in class there is some data and methods. So the data of that class can be accessed only by their methods. So that is one of the advantages. That is known as data hiding. Outside we cannot access this data and all. Then ADT based design displays high cohesion and low coupling because these are classes are high cohesive modules. So if you use this under abstract data type design, then it displays high cohesion and low coupling. That's what we want in design also, and also makes design solution easily understandable also because we have this high cohesion and also we apply the principle of abstraction here. So it is easily understandable because there is high cohesion and also we use the principle of abstraction. Inner details are hidden to outside people, so we need not worry what is happening inside. We have to see only the interfaces, what the data interchanges are need to be studied. So these are the advantages of data abstract data types or object oriented approach. Okay. So then if you see object oriented, both are there, we can use both approaches for our software design. So it depends on the convenience. So nowadays we mostly use this object oriented design for this developing this, because it has developed all through the years, it has developed this UML language and all. It is the modeling language that will be used. So but we will be studying both functional oriented and object oriented approach in this, like in this session. Okay, so that's all. Thank you.